a very neat problem, so I decided to record it today. I've already thought about it, and so let's go through it. Let's move this ducky away. Don't worry about that. But here we go. So I'll tell you the rough description of the game. The game is there's one robot, and one robot tries to get from here to here, to here to here, and the other robot tries to do the same thing. Now the thing is, the first robot takes a path such that whatever cells it goes to, the points get zeroed out. It basically steals and takes all the points. And all it wants to do is make the second robot get the least points possible. Okay? That's the idea. So my thought was, can I just make the robot, like, that robot take the maximum path? Because if the red robot takes the maximum path, my guess is that that means that the second robot will get the least number of points. Right? If you get the most points, you steal the most points away, so the second robot doesn't get a chance to get any of those high scoring points. And that's actually wrong. Let me show you an example. So here's the example. What if you had like 10, 50, and 20? And you had 100 and you had 0. Let's just say this. Or let's say this was 90. Okay? So let's say actually that the red robot is going to go on this path. So let's say this is 90, this is 50, this is 20, this is maybe 80, and this is maybe 40, right? Let's look at this case. So what would you do? You could go 10, 80, 50, 20. You could go 10, 80, 40, 20, but you would probably go 10, 90, 50, 20. So that little bit, if you're trying to maximize the number of points. So that means that you give the load of 80, 40, 20 to the blue robot. So in this case, the blue robot gets 80 plus 40 plus 20 points. Now, let me show you a better way to do it. What if that robot does this? 10, 80, 50, 20. That robot goes 10 plus 80 plus 50 plus 20. That's less than 10 plus 90 plus 50. But now the blue robot can't actually get both of these, right? The blue robot, sorry, this is 80 plus 40. Let me write that, because you can't get 20 points. 20, because once you reach, the red robot's always going to reach the destination. So 80 plus 40 points. But if you take this path, 90 and 40, you can only go to 1, because if you go down to 90, you can't go back up to 40. If you go right to 40, you can't go back left to 90. So the blue robot gets either 90 or 40 points, both which are less than 120. So this greedy way doesn't work. Okay? This greedy way doesn't work. Greedy does not work. So next question is, what do I do? Right? Well, there's a very nice, interesting constraint. Why did the author of this problem make it so that there's only 2 rows? Can we exploit that? Maybe we can. Maybe we can attack this problem exactly as it is. I found to figure out how to minimize the number of points collected by the second robot. So I wish I had a drawing for this. But I'll try to illustrate. You have 2, 5, 4, you have 1, 5, 1. Right? So you can try all possible paths. You can try, 2, 4, 1. All possible paths. What are all the possible paths? Let's just think about that. 2, 5, 4, you go all the way right, you go down. You go 2 right, you go down. You go right, you go down. And so, in all those cases, what are the bottom robot's points? What are the bottom robot's points? If you go 2 plus 5 plus 4 plus 1, you get these 2 points. Okay? You get the first, these 2 points. So all right, then the bottom robot points, the blue robot points. Now if you just go 2 right, that means you have to go down in right. So then you only have 1, 4. You have this guy left, and you have this guy left. 1 plus 4. If you don't go, so before you had 1 plus 5, 1 plus 5, you went all the way there. Now that you go this, right, down, you have 2 options. You can either attack this 4 and go down, or this 1 or 4. And if you don't go right at all, and you stay at, the robot stays at 2, and the red robot gets, then the blue robot gets 5 plus 4 points. So did we notice something? Did we notice that the red robot only has a few choices? You either go all the way right, you go 2 right, you go 1 right. It only has n choices, the number of columns. And if you think about it, this is why I would love a diagram, but it's hard, man. If you go all the way right, you take the bottom. Everything on the bottom, excluding this one. Basically, the idea is this. Whatever path I go, blue robot, it whatever path I go, you will notice that like in this case, okay? The red robot goes this. Then you have these 3 options. Then the red robot goes this path. And you realize that You have only two options, 15 and 1 and 3. And then you go this path, 1, 3, 3, 1. I'm just showing all the paths that I 1, 3, 3, 1. Then you have 1, 15, and 1 left. And if you go all the way down here, it's just 3 plus 1 plus 15. And so you can notice that the blue robot is always left with values only on the top or on the bottom, right? Like if I go 1, 3, 1, 15, 1, only these values are left. If I go 1, 3, 1, 3, 1, you say, yeah, you have 15 and you have 1, 3 left, right? But you can't ever hit both 15 and hit 1 and hit 1, 3. You can only hit either one, the top or the bottom. So then it becomes simple, right? You consider only a few set of cases you actually have to consider. You have to consider, in this case, the bottom 3, the top 1, and the bottom 2, the top 3, and the bottom 1. And I'm going to draw this out. So you're considering, in this case, what? You consider bottom left 3. Bottom left 3. Bottom left 2, top right 1. It's like bottom, then you consider this. Bottom left 1, top right 2. Or the only other case is top right 3. These are like the cases with the 2x4 grid. And you can very easily scale this up. Take these 3, take these 3, take these 2, take these 3, take this 2, and this 1. And you want to find the max of the top and of the bottom. So, okay, can we now code this up? So I'm just going to have two variables, bottom, top. And at the beginning, this is just how we're doing it. We're starting with this path, right? And so, here's the thing, like there'll always be 3 values, either somehow coming from the top right or the bottom left. Like you're kind of increasing the snake here, and then you're increasing the snake one side, and you decrease it. Right? You're moving the snake right from the left from one side, and you're moving the snake from the right one side. Right? So Um, you can actually reverse, like, do regular forward logic, right? What do you know? That you go from 0, your snake's all the way at the end, to n minus 1. Let's say n is length of grid 0, for I in range 0, n minus 1. And let's keep a sum of a top sum, 0, bottom sum is something, right? So in the beginning, two, three, four. 1, 2, 3, 4. And right now you can say that is this. So I'm gonna actually, this diagram shows the opposite, but I'm gonna start like with this one. Pretend this is the red robot, right? The red robot is basically, I'm starting with the idea that the blue robot, okay. You know what, it's gonna be easier if we just follow this diagram, because then you guys can see it clearly. So let's look at this. My top sum starts as what? 0, right? That is taking it all up. My bottom sum starts as what? Sum of grid 1, 2, so let's do n is length grid 0. Oh, we already did that. Grid n minus 1. Minus 1. Cool. And then we're just saying, let's shrink this caterpillar to the left and increase the other caterpillar. So for I in range, this was what? This was n, the nth minus second. This is n minus 1th element, then minus 2th index. So we're gonna go inclusive n minus 3, negative 1, negative 1, just saying go backwards until 0. And we're gonna take the bottom sum and subtract. Oh, so I'm gonna do n minus 2. I'm gonna say like subtract 3. Subtract grid of I. And then the top sum will be plus or equal to you had 0 elements before, and then now you have one element, two element, three element. You basically have what? What did we say? You have basically you take the bottom sum, subtract it from this top sum, and you just, what are you just doing? You're just adding an element every time you decrease one. So you can just say, you know what, I minus n minus 2. And then you can say, you can only go on one of those, max times sum, bottom sum. What's your points collected right now? Your points collected is the blues points min, that you want to minimize the blues number of points, is currently equal to what did we said? We said this. So when blues points is equal to bottom sum. Yeah. He got all these 1, 2, 3 points. And then min, like blue decides optimally I want to play this max top sum and bottom sum, but that says I want to minimize that. So min, blue points min, comma, points min. And then I should just be able to return blue points. Judging, int and list. What did I do? What did I do? What did I do? Bottom sum minus equal to. Is that right? Yeah, this is bottom, this is top. No. No. Okay. Clean technically doesn't work. Blue level is always left with values only in the top or in the bottom. But what did I do wrong? Let's just try that. 1, 3, 1, 15, 1, 3, 3, 1. The blue robot currently gets these. These are the blues. 1, 3, 3 are the blues. Right? So we have bottom sum is sum of 1 to n minus 1, which is yes. That is 1, 3, 3. Cool. So we got that, right? And then we say, take the bottom sum, subtract it from grid onto n minus 2 in this case. Subtract from 3. Right? N minus 1 element, n minus 2. Subtract from 3. So this is correct. So then we get this, and we add which element? Now going this way, so we add 15. We add 15. Add 15. Oh, so top sum is plus or equal to uh, 0 with adding the last element and the element before and the element before and so on. So one thing I could just do is I could say, you got a bottom pointer, you got a top pointer, right? So you can give a top pointer at, right? Instead of worrying about this logic, I'm just gonna say this. I'm gonna say, give you a top pointer here. What's your top pointer? Your top pointer is at, starts at n 0, 1, 2, 3, n minus 1, starts with the last element, top pointer. Then every time that your left pointer is going back and then moving, you're also adding from the left, so you're doing top pointer minus equal to 1. Cool. And yay, we got it.